Feeling pretty good after a good night? So this is where Cisco Live really gets its speed, right? We heard from Chuck this morning. How many of you guys watched the keynote? Fantastic. So what do we know? We know that traffic is going to increase potentially up to 3x with agentic AI. We know that network is critical infrastructure to run applications, to run all of these new wonderful innovations. So we have to make sure that we're able to operate and maintain those networks. And that's what we're here to talk about. How do we do that on a day-to-day basis as IT operators, both from the network and the security perspective? So thank you for joining the session today. When I started my tech career, I started in IT. This is me. I'm getting the page back in the day, BlackBerry, we got a buzz and said, there's something wrong with the network. There's an application that's being impacted. And this happens today, even now, with big, large, modern teams. We work with customers that have distributed environments, very complex networks, and they have to gather resources to try to understand how to solve the answer in as fast as they can with the right data. So that might mean they have to open up their screens for logs. They might have to go grab a certain expert that knows and understands the configuration of a network or an application, or bring in the application of the database teams. And everybody's working together in a war room. It's a very common scenario, and it could be tied to a security breach. It could be tied to a network performance. But applications are at modern enterprises. And so these are situations that we want to improve. In order to do that, we have to understand what systems are impacted. And so that's our session today. Talk about mean time to incidence, which is how do we identify where the problem might be? How do we do that quicker with the instrumentation and telemetry we have access to on these devices and networks? But then how do we use AI to accelerate that process? And how do we ultimately shorten this time? So improve MTTR. So historically, we know, how many of you all have used Wireshark in your career? All right, fantastic. Show me the PCAP. I need the PCAP. Where is it? Right? So as networks increase in speed, we need that packet data to provide the truth in the data of what actually is happening on the wire, either now or perhaps in past time. We also know that we can have other types of telemetry available to us. We have metrics. We might be using that from Grafana. We might have logs from Splunk. We might have flow data, which gives us that end-to-end picture. But we still don't know exactly where and why this problem is occurring. So we use Wireshark analyzers and we pull the PCAP that gives us that little segment to understand where that might be a problem. If it's a DNS problem or a TLS handshake, or if it's something to do with one of the other protocols that supports the network. Then we have dashboards. So I sat in front of the Cisco NOC, Cisco massive screen. Look at all those dashboards. Everyone loves a dashboard. Very colorful, wonderful information, great insights, but it requires an operator, a knowledge operator, in order to interpret those dashboards to find out what might be going on at that time, what might be causing that root cause, what might be impacting the network. And we have to analyze this. And these are great. They give us insights. They show us a little bit of history. And we have to process that as humans in order to find this information out. Well, now we have agentic processes. We have integrations with MCPs. We have LLMs that'll help interpret that data if we provide that data, the right data, to the models. And that's what we're here to talk about. How can we improve that? And that's really where things are accelerating and helping us as operators to manage these complex networks and applications. So we know that LLMs are very powerful. They rely on real-time operational data. That data is available to in troves. These are up to petabytes of data that we have access to now, but we have to mine that data. LLMs are not good at crunching huge volumes of data. That's where we have machine learning. They're very good at looking at metadata, and that's what we're going to talk about a couple use cases. We also know that to get access to that, the LLMs need MCPs as a way to communicate. And this is also important is when you're thinking about network observability, does your provider have that supportability? Do they have that integratability with your current tool chain? And how they expose that information over time. And then how do we turn that into real business outcomes? And that's how we collapse the cycle, how we shorten the number of people it takes to solve this, and we improve the time for resolution, but we also reduce the resources that it takes to do it. So we really want to change this congested moment where everyone's stressed and trying to figure it out and start moving to this type of model, right? Where we can start interacting with the data. We can start interacting with the network metadata that gives us insights. It could be the topology. It could be changes that are occurring between the application, the server, and the network all at once that are going to start seeing those patterns through the intelligence of the large language model. So one of the things that we're doing here at cPacket is working on improving the incident response by providing the relevant data to the operators, either NetOps or SecOps, typically in the form of a report that you can query. So once you know that if it's a network problem with slowness, if it's a connectivity problem, if it's a capacity problem, if it's something that has to do with a handshake, that you have some indication from either users, if it's reactive, or maybe from a synthetic test, if it's proactive, that gives us the insight to start doing the triage. Now, we also have to have proof. We have to have evidence to build trust in the AI report. And that's where the quality of the data and the reasoning of that data becomes so paramount. We also need to have reasoning based on facts, things that we know were not hallucinated, but based on real-time operational insights that we get. And that feeds into an RCA analysis of the root cause of that problem. And that compresses that time frame in that war room, so we have less resources and less time to get back to normal operations. So this is the punchline slide. If you want to take one picture, this is it, right? This is the theory. We really want to operate quicker when we have more complexity, more diverse networks, more distributed applications, and we can do that by enabling workflows. And I'll walk you through what that looks like. Packets are defensible proof of a particular insight that we need to defend when we go into that war room to understand, hey, we think this is a DNS problem. Hey, we think that this is connecting over here and we see these retransmits or we're seeing delays. This is the root cause. And we have other evidence from different protocols that all comes from packet metadata that we could get and aggregate over all these different monitoring points within the network. The other thing that's really important is that we have to maybe enrich that data set to the point where a non-super engineer can start interpreting that information. That's super important because, as you know, it's hard to find really, really good network engineers that can understand complex networks and troubleshoot at machine speed when the data volume is going up and agents are running at machine speed. Those people are fantastic engineers. But if we can take their domain knowledge, work with them, augment that data, and build workflows, we can start distributing that information to different groups. That really helps with security investigations, where the network team's providing packet data, providing insights to the security teams during an investigation for forensics, for auditing. And that really helps shorten that process as well. But we also know we operate in very strong compliance regulatory environments. A lot of our customers operate large mission critical infrastructure, financial applications, healthcare applications, government systems, and they need to protect that data. And so having that evidence and having it also be sovereign data that they can retain and have proof and auditability is part of their regulatory requirement. So let's go through two examples. First is if you take a traditional situation where you know there's an issue, and you look at the number of resources that it takes to try to triage that process. It might be 2 engineers, and they're pulling up multiple dashboards, maybe 3 dashboards. And this takes maybe an hour, maybe 90 minutes. Well, you're basically saying, collectively, what do you think is the root cause? But as we start exposing some of this data to the LLMs through the MCP and start enriching that data with skills, we now start to empower others to gather that insight, to shorten the time, to shorten the number of resources, and that really provides better ROI. And we know that in financial services, oftentimes downtime or even latency can impact revenue. And a lot of our customers have things like market data feeds, they monetize. And so if any of those applications are dropping packets, they're having buffer overruns by microbursts, things like that, those are mission critical to their business. But if we can shorten that process, that's actually going to help their teams operate more faster, more efficiently, and also diversify the skill set. We also know that in a healthcare, we've worked with a large healthcare organization that was having a DNS problem, right? So many requests coming out, not enough response time, or the receivers were overloaded, right? And so that's going to start impacting the handshake of the process as it goes through the application enablement and connectivity, where somewhere one of those protocols is slowing down, it's going to impact the application speed. So we know that the application's up, but it's slow because perhaps DNS is delaying that process. So we have to triage and troubleshoot DNS. Now, to do that at the packet level, we have to know exactly where in the network, when it happened, right? What segment, what time frame. And if this is operating up to like 100 or 400 gig network, sample data through some sort of metric or flow isn't going to give you that root cause data that's going to feed the analysis within the LLM. So we want to make sure that we have all of that rich insights at the fingertips of our analysts, and to make sure that we're able to do that with proof, with defensible data. This is something that you heard Chuck during the keynote. We talk about data sovereignty. Eventually, there's going to be some conversation around AI sovereignty. So yes, I want to protect my data, but how do I also protect my AI? Because that has insights into all of the interesting things about if I'm in pharmaceuticals, right? And I know how to make drugs. Or if I'm in financial services and I have a calculation to know which is a good trade or not. All of that data is private data. If that gets trained into AI, I need to be able to protect that. But that also means I need to observe that data, those systems, those applications. And that's hard. So that's something that we pride ourselves on is, as you start modernizing these different AI architectures, we also have to modernize how we do observability in an air-gapped environment, which means you're not as dependent on shipping all of that metadata into a cloud, into SaaS, but you have direct access to that. So as you start reasoning over this with your LLM of choice, your preferred LLM that your IT and security teams have given you, you can use that LLM to reason over all of this rich machine data. And that's super important as you start building these modernized workflows, right? Being able to have the controls in place so that as you start gathering more and more of these insights, you're not exposing that data to other, let's call it, negative agentic processes or negative human interaction with that data. So that's where we come in, right? So cPacket, we've been in business for over 20 years. We started as a fabless semiconductor. We built some super high performance packet brokers that operate with FPGAs and ASICs. And we put smart ports on each monitoring point that allows us to run filters, run complex evaluation of packet-based data that includes things like burst analysis, market data feed analysis, and that allows us to create an aggregation layer, moving up to an intelligent layer to do time stamping that gives us very, very detailed latency down to the milliseconds for operations like financial service application monitoring. We also start to collect metadata at the time that we see the packets, and we feed a lot of that metadata to ourselves and to our ecosystem. And some of our partners are here today. So we have high performance packet capture appliances that have different sizes for different use cases that allow us to do write to disk without losing packets, up to 200 gig, proven by the Tolley Group. All of that information is capturing that metadata at line rate. So we're writing to these buckets based on protocol, based on connectivity, based on RTT, based on all of the IP map information that we need to maintain. We replicate that data up into our control layer, which we then expose to MCPs. So we have multiple MCPs across each part of this whole stack that allows you to build an architecture for a particular environment or application, like a healthcare application where you have distributed hospital sites, where you need to look and see if you have malware traversing your network across multiple different hospitals. And you can use that by centralizing all of your queries at the analytics layer, and it goes down to the different repositories that gives me those insights. Or if I needed that PCAP file we talked about in the beginning, I can quickly request that through an API. And so we've recently built an integration with Corelight, our NDR partner, for a large transportation company with petabytes of data that allows them to very quickly, during a threat investigation, through an API, access full packet transparency on any type of profile that they deem as potential vulnerability, and it queries petabytes of data in order to understand where it might be impacting the application, the users, where they may be in violation for compliance. And so that's super, super hard to do. To do this at the speeds that we do, to do that, to be able to write to disk, to index it, to search it, and to retrieve that information and to feed that into AI. That's what we do at cPacket. We also have something that I haven't heard a lot of vendors talk about at Cisco Live, which is this concept of knowledge. And we talked about that slide. Remember the triangle at the top? Knowledge oftentimes comes from humans. And that human knowledge can be transferred into workflow that kills this. Is this a connectivity issue? Is this a latency issue? And the LLM can be trained to augment that knowledge and actually accelerate the troubleshooting process by reducing the number of tokens to reason to get to root cause. So we are building at cPacket a library of use cases based on skills that you can import into your LLM to reduce the time it takes to get to root cause. We also have an insights capability that can look at anomaly detection, and we can feed all of that data to our ecosystem. So this is about getting better return on your investment of your existing tools. This is by collapsing the number of tool vendors. Perhaps you have a broker vendor and a capture vendor and an analytics vendor and an AI vendor. Well, if you start to collapse that, we get better efficiency. We also get better accuracy, and we can also get better investment of your other investments, like your NDR investment. So if we can supercharge your NDR with all of this rich data, that really ultimately helps the security analysis, the CV evaluation, and getting to root cause quicker when you have this large distributed network. So that was a lot. I appreciate your time. So I'm just going to summarize here and talk about a few things. First of all, we were right over there. Thank you for coming over. If you just had a chat, we have 2 demo stations we can go through. All of these workflows that we talked about, we have demos across 5 different use cases that are very specific to you. So the question is in your environment, in your industry, where are those problems? How can we augment your teams? How can we use AI and workflows and these skills and knowledge to accelerate your challenges? And how do we create that great outcome that we want, right? We want smaller war rooms. We want less resources. We want to empower others. We want to expose the right data to the right people in a controlled way so that we meet our IT requirements, our security requirements at the same time. And that's something that we're focused on here at cPacket. We like to collaborate with our partners. We're a small company, we're agile. We have very large customers. And some of them are here, that we appreciate your business. We're here to innovate using all of this great technology to help you guys on your day-to-day job. So thank you so much for the time. Love to come have some more conversations at our booth. And you all have a great day. And I'll leave you with the last thing. The answers have always been there. You just have to ask the right question. Great. Thank you so much.
Let's round of applause, please, for Erik. Great presentation. Very smooth. Speaking of questions, anyone have any questions out there? Anybody? Comments, concerns? Yes, sir. Coming right over. What's your name and where do you live?
My name is Suman. I live in Minnesota, Minneapolis. The question I have, like how long the data retention, like can I keep for a whole month, 6 months?
How long, the question was, how long can I keep the packet retention? So there's a couple variables. It depends on if you're collecting the headers or the full packet. And then it comes down to your hard drive space. So we can architect a system that says, okay, I want 30 days, I want 45 days, I want 60 days. If you want full PCAP and you're running a 100 gig or multi-mesh 100 gig network and you're monitoring all of that, you can do the math. You can figure out the number of terabytes or petabytes you need. So a lot of this depends on the use case and if you need to have the full payload. And then also if you want to have object store that you can offload. So some of our customers offload to S3, some of it offloads to very large JBODs that can be attached to our capture appliances. We have some customers that have 20 plus petabytes of packet data, which represents anywhere from 30 to 45 days.
Good Lord, that's a lot. That answer your question pretty well? Excellent. Anybody else? Comments, concerns? All right, guys, thank you so much. Big shout out to cPacket.